There are a couple of questions I was asked about for linear approximations and differentials, questions 5 and 6, and they're a little picky, and this is where I'm going to warn you about these problems and how we do this. So it's here, the issue is right here, and it took me a while to figure out what the problem was. Plot the point on the tangent line that approximates this using, so we're going to draw the tangent line, and there's a second part, plot the point. That part I was missing. Okay, so let's go ahead and look at this problem. The graph of the function f of x equals x squared plus 1 is shown. This is the graph. We have f of 1, and this corresponding y value, 1 squared plus 1 is 2. We have f of 1.1, so 1.1 squared is 1.21 plus 1 is 2.21. That's right there. So we're going to draw the tangent line to this point here and plot the point on the tangent line that approximates f of 1.1 using the differentials. Okay, so let's jump over here for some workspace. And I'll have, this is number 5, and we'll do number 6 over here. We have f of x equals x squared plus 1. And as I stated, f of 1 is going to be 1 squared plus 1, which is 2. So we know we have the point 1, 2 to work with. Now let's look at our slope. Now f prime of x gives us the slope, that's 2x. And our slope at x being 1, at the point we're talking about for the tangent line, is going to be 2 times 1, which is 2. So with this point and slope, we can do y minus y1, which is 2, equals m, which is 2, this is our m here, times x minus 1. Y minus 2 equals 2x minus 2, so plus 2 plus 2, y equals 2x. So if we want to find out what the slope is going to, or the other point's going to be, excuse me, at x equals 1.1, y would equal 2 times 1.1, which is 2.2. So 1.1 corresponds to 2.2. So let's take that information and come back to our graph. So here's 2.2. So I'm going to, first thing it wants us to do is draw the line. Boom, here, and the other one's here. The second thing they want us to do is plot this point. Plot the point right there. Okay. Let's see if it's correct or not. Hey, I got it right. So the key to it that I was getting it wrong before was I didn't plot that second point right there. Okay, let's go to the next one. And it says the graph of the function f of x equals sine of x plus 6 is shown with the points -6, f of -6, and -5, f of -5. So here's -6, f of -6. You can just do that in your head if you want. -6 plus 6 is 0, sine of 0 is 0. And then we have, here's our f of -5. But we're going to be doing a tangent line here. So we have to come up with this second point here. So we're going to take the derivative, come up with the equation of the tangent line, and then we can come up with the other point we're going to plot. So this is f of x equals sine of x plus 6. Just as I stated, for x being -6, f of -6 is going to be sine of -6 plus 6. So it's going to be sine of 0, which is 0. So we have the point -6, 0, as we saw on the screen. I'm just verifying that. So we now would take the derivative to find the slope at this point. And this again will give us the slope at every point. And we plug in our numbers. So it's going to be sine, no, derivative of sine, we all know what that is. It's cosine. It's cosine of x plus 6. And the derivative of x plus 6 is just 1, so I don't have to worry about the chain rule here. So we look at that derivative at -6. So it's going to be cosine of -6 plus 6. or cosine of 0, which is 1. So we'll have y minus the y value here, by the way, that's our m. Y minus 0 equals 1 times x minus negative 6, or y equals x plus 6. So the question is, what happens at, what was the other point? Let me jump back here. Was it 5? Negative 5. Okay. So if x equals negative 5, y equals negative 5 plus 6, which is 1. So negative 5 corresponds to 1. Okay, so going back to our graph, if we're going to graph it, we have that point, and we know it goes through negative 5, 1. Then it wants us to plot this point as well. And then we can see if it's right or wrong. And it's right. Okay, yay, it worked out. Hope that helps.